Hello everyone. In this video we will see the analysis of a girder. We will find bending moment due to live load and we will also find shear force due to live load. So this is lecture number 13. We are into bridge engineering series. Okay, so this video is about analysis of the analysis of the longitudinal girder. Analysis of the longitudinal girder. So longitudinal girder will be analyzed for two loads. One is the live load and other is the dead load. So we will find the bending moment and shear force due to live load. And in the next video, we will find the bending moment and shear force due to dead load. So design of longitudinal girders involves evaluation of live load, design of longitudinal girders involves the evaluation of the live load, live load distribution. So the live load is acting on the deck and that live load has to be distributed to the to the girders. Girders is below the deck, okay. So the design of longitudinal girders involve the analysis, means it involves the evaluation of live load distribution amongst the girders. Live load distribution among the number of girders used in the deck. So with three or more girders, the load distribution is estimated by the following methods. So there are three methods by which the live load distribution can be calculated. See, the live load is acting on the deck and the girder is below the deck. So we need to distribute what is the live load in particular girder. Okay, so there are three methods. Number one is Corbin's method. Number two is Guyon-Maisonnet method. And the third one is Henry-Jaeger method. So amongst these methods, the Corbin method is the simplest method and it is applicable with some conditions. We will see what are the conditions of the Corbin's method and how it is applicable to find the live load distribution of a particular girder. Okay. So first we will see the conditions of the Corbin's method. Conditions of the Corbin's method. Number one is A. The ratio of span to width of deck is greater than 2 but less than 4. The ratio of span to width of deck is greater than 2 and but less than 4. Now in our case the span of the bridge is 30 meter, okay, and the width of the bridge is, the width of the carriageway is 7.5, and you are providing 1 meter and 1 meter. For example, you are providing 1 meter, 1 meter, the footpath. So total width of the bridge is 9.5. Okay, span to width 30 divided by 9.5. So what it is coming? 30 divided by 9.5. Let me calculate. 30 divided by 9.5. You're getting 3.15. So we can apply it to our case. Okay, so the ratio of the span to width of deck is greater than 2 but less than 4. Okay, we can apply to our case. Second condition is B. Condition B of the Corbin's method is the longitudinal girders are interconnected. The longitudinal girders are interconnected by at least 5 symmetrical cross girders. By at least 5 symmetrical cross girders. So here the span of the longitudinal girder is 30 meter, and at a distance of 5 meter cross girders are provided. So it will be 5 cross girders, because at 5 meter interval the cross girders are provided. Okay, so it will be more than 5. So this is cross girder, this is second cross girder, third, fourth, 5. It will be more than 5. Okay, so second condition is also satisfied. Third condition of the Corbin's method is, third condition C. The cross girders extend to a depth of at least 0.75 times the depth of longitudinal girders. The depth of the cross girders is equal to 0.75 times the depth of longitudinal girders. And we have not yet seen what is the cross section of the longitudinal girders and what are the cross section of the cross girders. What we will do, we will provide the depth of the cross girders equal to 0.75 the depth of the longitudinal girders, so that the condition is satisfied and we can apply the Corbin's method. Okay. Now we see how to put the live load in the cross section of the bridge. So this is the cross section of the bridge that you have. Okay, so the footpath is 1.5. More or less you will get the same. Okay, footpath is 1.5, and this is the deck that you have. Then below the deck you are providing the longitudinal girders like this. There are 4 longitudinal girders that is there in the bridge. Okay, this is the last longitudinal girders that we have. Okay, and the center to center distance between them is 2.5 meter. We have seen this in the problem. Center to center distance between the longitudinal girders. Then you are providing cross girders like this. Cross girders is in this way. Okay, it is spanning in this direction in the cross section. Okay, so how you putting the load? The load is class AA tracked vehicle. So you are putting the load to, it is having 2 tracks. You are putting one track here and you are putting another track here. Okay, and the distance of this track from the edge of the footing is 1.2. So this is called clearance. We are providing 1.2 clearance when we are putting class AA tracked vehicle, and the width of one track is 0.85. This is also 0.85. the clear distance between the track is 1.2. Okay, so the total weight of the class AA tracked vehicle is 700 kilonewton. So weight of one track is 350 kilonewton, weight of another track is 350 kilonewton. So in this way you need to put the load, and we will see this is the live load that we have. It is acting on the deck. We will see how it is distributed to each deck by using the Corbin's method. Okay. Now here, when you are using the Corbin's method, you need to define the central axis of the bridge. This is the central axis of the bridge. Central axis of the bridge. The distance of the girders, you need to see what is the distance of the each girders. Girder A, girder B, girder C, girder D. A and D are the outer girders, B and C are the inner girders. Okay, we need to see what's the distance of this from here. So total distance is 7.5, 2.5, 2.5 plus 2.5, 7.5. 7.5 divided by 2, here this is you are getting 3.75. You also have to define the distance of the central axis of the load with respect to central axis of the bridge. So this is known as eccentricity. So here, from here, the distance is 1.2, 1.2 plus 0.85 plus 1.2 divided by 2. Then you have this distance 3.75. 3.75 minus this distance, E value you are getting as eccentricity equal to 1.1. So this data will be used in the Corbin's formula. I will tell you what is the Corbin's formula. Okay, we will see this. We need to find the reaction factor by using the Corbin's formula. Reaction factor, what is the reaction at girder A, what is the reaction at the girder B. So from the reaction, we will find the load intensity. So reaction factor equal to summation of W divided by N bracket 1 plus again one more bracket summation of I dx into E divided by dx square into R, bracket closed. So we will see what is Rx. Rx is the reaction factor for the girder under consideration. So you have 4 girders, and you can simplify that. Whatever the reaction factor for girder A will be there, it will be same for girder B, and whatever reaction factor for girder B will be there, it will be same for girder C. So you need to find the reaction factor for the outer girder and the inner girder. So these two, the reaction factor will be same. Okay, so reaction I will write here. Reaction factor for the girder under consideration. For the girder under consideration. Then you have I is the moment of inertia here, and here you have the I. It is the moment of inertia of longitudinal girder, moment of inertia of longitudinal girders. Then you have dx. What is dx? Distance of the girder under consideration. You need to see which girder you are considering, whether you are considering girder A or girder B. Okay. So distance of the girder under consideration with respect to central axis of the bridge. From the central axis of the bridge. Okay, so already we have defined this dx. In our case, for example, if you are considering girder A, the distance of girder A from the central axis of the bridge is 3.75. If you are considering girder B, so the distance will be lesser, okay, with respect to central axis of the bridge. We will see. So first we will consider girder A. We have the distance of dx. that is 3.75. Okay, then N is W is the total concentrated live load. W is total concentrated live load. Total concentrated live load. Then we have N. N is number of longitudinal girders. Number of longitudinal girders is eccentricity of live load with respect to central axis of the bridge. This is eccentricity of live load with respect to central axis of the bridge. So already we have calculated eccentricity. What is the eccentricity of the live load with respect to central axis of the bridge? E, that is 1.1. We can use the formula. You can find RA. RA equal to, RA means reaction factor for girder A. W, we will not put W. W by, there are 4 number of girders. Okay. 1 plus, there are 4 girders, so we need to write 4I into 3.75 is the dx into E is 1.1 divided by 2I. 2 girders are at a distance of 3.75 meter and 2 inner girders are there, 2I, and distance of those two inner girders with respect to central axis of the bridge is 1.25. Okay, so I will show you. These are the inner girders. The B and C are the inner girders, and the distance of inner girders with respect to central axis of the bridge is 1.25. This is summation of dx square I. You need to consider all the girders here. Okay, reaction factor RA equal to 0.382 W. Okay. Now intensity of girders on intensity of the load on the girder. How to find the intensity? Yeah, we have got a reaction factor. This is the reaction factor which is acting on girder A. From the reaction factor, we are required to find the intensity of load on girder. So we will see how to find that. Intensity of the load on girder A. Girder A. Okay. Equal to load into impact factor. Impact factor divided by contact length of the load. So contact length of the class AA tracked vehicle is 3.6. So already we have discussed what is class AA tracked vehicle and what are the contact length of different load. So you can refer that video and you will find the dimension of different loads. Okay. So contact length of the load is 3.6. Here we will write contact length of the load. Contact length of load. Okay. So load is 0.382 into W. W is 700 kilonewton. Class AA tracked vehicle is having 700 kilonewton into impact factor. So length of the girder is 30 meter and impact factor for 30 meter for IRC class AA tracked vehicle is 1.1 meter and we are getting this value from IRC 6. Okay. Divided by contact length, that is 3.6 meter and this is coming as 81.71 kilonewton per meter. Okay. Similarly, you have to find the reaction factor in inner girder, in RB. Reaction factor for RB. Okay. So W by 4 will be there. 1 plus 4I into, here there will be change. It will be 1.25 because the distance of inner girder with respect to central axis of the bridge is 1.25 and all the things will be same. Okay. 2I into 3.75 square plus 2I into 1.25 square. So RB equal to 0.294 W. Okay, and Similarly, we need to find the intensity. In the same manner, we are required to find the intensity of load on girder B. Intensity of load on girder B equal to load into impact factor. Load is 0.24 W, that is 700 kilonewton, into impact factor 1.1 divided by contact length, that is 3.6, which is coming as 62.88 kilonewton per meter. Now we have calculated the intensity of the load on girder A, that is 81.71, and in girder B is 62.88. So girder A is the critical girder because the maximum load is on girder A. Girder A is the critical girder. We can analyze the girder A because it is having the maximum load. Maximum load is on girder A. Girder A, that is 81.71 kilonewton per meter. And the span of the girder is 30 meter. Okay. And we need to put the load. So to get the maximum bending moment, we can put the load exactly at the center so that we will be getting the maximum bending moment. The contact length of the load is 3.6 and the intensity of the load is 81.71 kilonewton per meter. Okay. So the maximum bending moment is, I'll write directly, maximum bending moment is equal to 81.71 into 3.6 divided by 2. This is the reaction that we are getting into 15 minus, then you have this much of UDL, you have 81.71 into 1.8 into 1.8 divided by 2. So the maximum bending moment you are getting it as 2073.8 kilonewton meter. This is the maximum bending moment due to live load. Okay. Now we will see how to find the bending moment due to we will see how to find shear force due to live load. Okay, so you have 4 girders like this. There are 4 girders. Okay, and there are cross girders like this. So this is A, B, C, D. Okay, so the longitudinal girders are 2.5 meter distance center to center and cross girders are 5 meter center to center. Okay, now here we need to put the load in such a way that one track is on the girder. For example, this is one track is coming on the girder and another track will be between B and C. And center to center distance, we are not putting the clear distance, we are putting the center to center distance. Clear distance is 1.2. Center to center distance between the track is 2.05. And since this is 2.5, this distance will be 0.45. So you need to put the load in such a way that one track is on the girder and another track will be on the deck. Okay. The contact length is 3.6 meter. Okay. Okay. So we will see the cross section. We will look in this way. We'll see the cross section. When you see the cross section, here you have girder B and here you have girder C. On girder C, one track is, we have put one track on girder C, that is 350 kilonewton. Another track we have put here at a distance 2.05 from C. This is 0.45, 350 kilonewton. So we need to find the reaction. Here the reaction is 287 and here the reaction is 413 kilonewton. Okay. and the maximum reaction that you are getting on it is on girder C. So we need to analyze the girder C. Girder C is the critical girder. Okay. So I will draw girder C. I will draw girder C, and this is 30 meter. So how we have put the load? We have to put the load at the it should touch the support, so that we will be getting the maximum shear. The head of the UDL should touch the support. And how to find this intensity? Already we have gotten the reaction on girder C. Reaction divided by contact length. Okay. So this is coming as 114.72. And maximum reaction you will be getting at the left support. That is 388.21 kilonewton. Okay. And how to find maximum shear? Maximum shear due to live load with impact in the inner girder. Maximum shear due to live load with impact in inner girder. Equal to 388.21. Impact factor is 1.1, and the shear force due to live load is 427.04 kilonewton. So we have calculated two things here. We have calculated live load bending moment, that is 2073.8 kilonewton live load bending moment, LLBM, and we have also calculated LL live load shear force, which is 427.04. Okay, so thank you for watching this video. In the next video, we will see how to find the dead load bending moment and dead load shear force. Okay, thank you very much.